Hey guys, welcome back to another dynamics video. This one's again going over our special points topics. It's gonna be a lot of special points videos. This one is gonna be about using acceleration. All right, that acceleration equation in special points instead of velocity. I know a couple of you were having a little bit of troubles with this problem. So this is actually gonna be one of the problems where we do need to use the acceleration equation, not just the velocity equation. I'm pretty sure on the exam you'll either have to use one or the other. So if you need the acceleration, you'll be given the angular velocities. You won't have to solve for that and then plug them into another one. That might take too much time. And then if you just need the velocities, obviously you don't need to solve for the accelerations. But anyway, so let's get into this problem. So the problem states that the red link AB is 3 meters long, so 3 meters. The blue link is 2 meters long, so 2 meters, and is currently vertical. The black box is trapped in a slot and can only move vertically. At the present, C is moving up, right? So it's got a velocity upwards, unknown, it's not giving it to us, and has an acceleration down of 2, right? So this is 2. So what else? Okay, so let's mark that this is acceleration so I don't forget. Currently, the red link, it has an angular velocity of 4 counterclockwise, so it's going in this direction with a magnitude of 4. And the blue link has an angular velocity of 0, so this thing has 0 angular velocity. So what is the angular acceleration of the red and blue links? Okay, so you notice that it's asking for an acceleration, right? So we are going to need to use the angular acceleration equations, right? Or those general equations. So let's do some analysis first and write down what we're given. So we know a couple things. We know that the velocity of C is unknown, but they gave us the acceleration of C, right? And if we draw our I and J components, so J going up and I going to the right, then this C dot, or this C block, is accelerating downwards, right? Because it's the opposite of the J. So that's negative 2J. That's our acceleration for C. We know a couple of other things. We know that the angular velocity of the red link was given as, what did it say? Given as 4. So this is 4 counterclockwise. That's a positive k direction. And then we know that the blue link is 0. Right? 0k, or just put 0. Is that all we know? Yeah, basically. So at this point is we're going to have to start writing our acceleration equations. So if you don't remember them, let me actually pull one up because honestly I don't remember them either. I have one of them. Okay, here it is. So the general equation when we're doing acceleration problems is this. And it's that for any body, right, we have 2 points on it. So let's call them little a and little b. So acceleration of little a equals the acceleration of little b plus the angular acceleration of whatever body they share times the cross product of the position vector. I'm going to write it as a lowercase r. From B to A, right? So same thing as the other equations, we're always going from the one on the right to the one on the left. And then that is a little bit more terms than the one we're used to, minus the square of this magnitude for the angular acceleration. One thing to note is that this W, and the other equation, the W, or the only W in there, is a vector for our angular acceleration. In this case, we're just getting the magnitude of it, right? So this isn't going to have an I or a J component. This is simply going to be the value that we have for whatever our angular velocity is, squared, right? So it's a scalar. Okay, so that out of the way. That and then just times the position vector, right? So the same position vector as with the one we just wrote. So this is just a normal multiplication because these aren't vectors. Well, one of them is a vector, but the W squared isn't a vector. From B to A, I keep writing it as the big R, which that's how it is in the formula, but I prefer the little r. And then we have more terms past this, then plus 2, and then W. Now this one is a vector, this W. You can tell because there's a cross product. With the cross product of the relative velocity, right? And then plus the acceleration relative. Okay, so this is our general equation. Now let's make it specific for this red and this blue link. So I'm going to do the red link first, right? So the red link has special points B and special points A, right? So these are the 2 points that I'm going to use in my analysis. Something to always keep in mind is that you want to keep it convenient and keep your algebra simple at the end. So for me, since B is connected to both the blue and the red link, I'm going to keep B on the left side for both of my equations, right? So starting with the red one, I'm going to keep B on the left side. A will also go on the right side. And then we have to finish this out. So the angular acceleration is unknown. That's what we're solving for. Of this red link times the cross product of the position vector from A to B, right? So from the right to the left. So from A to B, if I'm traveling on this line, right, I'm going to B, I'm going 3 meters. And that is in what direction? That is in the positive I, right? So 3 in the positive I. And then minus, and then this is just going to be the magnitude of the angular velocity of the W, or of the red one, which is just 4, it was given, squared. And then this is regular multiplication times the what's called position vector we just arrived at, so 3i again. And then plus 2 times the W. So the W was, again, 4k, right? And then cross product of the relative velocity between A and between B. Now these relative velocities, since these things are on the end of a fixed length rod, they're always going to be 3 meters apart. So that's just 0. And then plus the acceleration, right, for the same reasons, is also going to be 0, right? So I hope you guys can see. It's weird because I already did it in red, but these are just kind of disappear, right? So now there's one thing I didn't make disappear, and that's this one. I kind of just left it. But if you notice, A is on a fixed point, right? So that thing has no acceleration and no velocity, right? So I can actually just get rid of this term as well. So this term also becomes 0. So I have that now AB equals, and then I'll multiply these out. So multiply these two for these constants. That's 3, and then the alpha R. Not B, R, right? And then this is I didn't write it explicitly, and I should have. This is in the positive k direction, right? We're just assuming. So this is a k cross I, which is a j, just positive j. Cool. And then now this term, this is just 16 times 3i, right? So that is going to be 48i, so minus 48i, right? And that's the whole term. So now we can do our blue equation. So for our blue equation, we'll do same thing where we keep B on the left side. And now C is my other special point, right? So C will be on the right side, so the acceleration of C. And then plus the angular acceleration of whatever this thing is, right? So it's the blue rod, right? And that's assuming we're in the positive k. Just always assume that. And then cross product of the position vector from C to B minus the velocity of the blue one, right? Just the magnitude squared. And then the same position vector, C to B, plus, and then same thing, 2 times that W of B again, cross product of the relative velocity plus the relative acceleration, right? My handwriting got a bit sloppy there, but you get it. Okay, so let's see. So the acceleration of B equals, and then the acceleration of C was given, right? Since it's in this slot, it told us it was going downwards with a 2 magnitude. So since it's going downwards, that's the negative j. So this is negative 2j, right? Plus, and then we're going to do this, write it out. So let's do, this is, what's it called? We don't know this value, so that's just B. And the cross product of what is this position vector. So this position vector, if we're going from C to B, which is what this tells me to go to, is I'm going up, right? So up, that's positive j, 2 meters, right? So this is just a plus 2, j. Minus, and then it told us that WB was 0, right? So I hope you guys can see that the rest of the terms are also going to be 0, but we'll write them out just to be specific about it. So this is also still 2j, right? And then plus 2 times 0, which is the given value, times whatever the relative velocity is, which is also 0, plus the relative acceleration, which was also 0 for the same reason. All right, so I hope you see that this term, this term, this term all cancels out because I'm multiplying by 0 somewhere in there. And now we have that for my blue rod, my acceleration in the B is negative 2j plus, and then I'll do the multiplication here. So that is plus 2 alpha b, and then k cross j is a negative I, so this is I, and then this becomes a minus, and then that's it. Cool. So since this, I'm actually going to move this thing over a bit just to save some room. Okay, so now I have this equation over here for acceleration of b and acceleration of b here. So since they have I and j components, they're vectors, I can equate these two things to each other, right? So in my I component, let's write the red equation on the left side. So my red equation in the I have negative 48 equals my blue equation's I values, which are just negative 2 alpha b. So negative 2 alpha b. Cool. And then my j components also add up. So that is this. So my j is, from the red equation first, is 3 alpha r is equal to, j from the blue equation is just negative 2. Right? Cool. So now I can solve for these. So just do a little bit of algebra. The blue, what's it called, acceleration, angular acceleration, is negative 48 over negative 2, which is just positive 24, right? So since positive 24, that's going to be in the counterclockwise direction. That's just a positive k. And then my acceleration, angular acceleration for the red is negative 2 over 3, right? Or about negative 0.66, right? Repeating. Since it's negative, this thing is in the clockwise direction. And that's going to be the actual answers for this problem. So I hope you guys got that and utilized this. So again, the accelerations aren't too tricky. The only really thing it's adding is this term right here, or these terms if you have a relative acceleration. It's unlikely that you'll get a question on the exam where you need to do first get the velocity vectors and then the acceleration vectors. Usually that takes too much time, and on exam you'll get, if you need the acceleration, you'll be given the velocity things. But just keep a lookout. So that should be the end of this video. Again, like always, you can let me know if you have any questions. See you.